this video we're going to look at the Fourier series of odd and even functions. This features in a past exam question, which is part A of question 5 from 2018. So we'll have a look at that exam question now. Question 5, part A. So it says, assume that f of x is a function with a Fourier series looking like this. This is the standard form for a Fourier series in the range minus pi to pi. And we want to prove that if the function f of x is an even function, then the bn coefficients, the coefficients in the signed functions, will be 0 for all n. And if f of x is an odd function, then the an's are 0 for all n greater than or equal to 0. Okay, so let's see how we'd address this question. So the first thing I would do would be to give the key definitions, just to illustrate to the reader that you know what you're talking about here. So we say f is an even function if the following holds. For every x, f of minus x is equal to f of x. Okay, so the function takes the same value on positive and negative arguments of the same absolute value. And f is an odd function if, well, for every x, f of minus x is minus f of x. So this kind of says that when you change the sign of the argument to f, that the sign of the value changes. Okay, then I would say that it can be shown using these properties, or using these definitions, that f is odd implies that when you integrate from minus pi to pi, when you integrate across any interval centered at the origin, you integrate the function f of x dx, you will always get 0. Okay? Because whatever contribution f is making on, say, the positive half of the interval between 0 and pi, it's making exactly the negative of that on the negative half of the interval, 0 to minus pi. So the two contributions to the overall integral are going to cancel out. Okay, we discussed that in detail in the lectures. So we have this important fact. Then I would say that note that functions, or that the function cosine x is an even function. Okay, it's a basic property of the cosine function, that cosine of minus x is equal to cosine of x. And the function sine x is an odd function. Basic property of sine, that the sine of minus x is minus the sine of x. Okay, so now suppose that the function f of x is even. Okay, so when you're getting the Fourier coefficients, you're integrating the product of f with one of the basis functions, either the constant function 1 or the cosine functions or the sine functions. So which one is going to be odd and is going to give us 0 here? Well, it's going to be when you multiply this even function f by the sine function. Okay, so note that when you take the product f of x times sine of x is an odd function. And you can just get the little proof of this here. The reason for that is that when you evaluate this product f times sine at actually I mean having any n in here, actually having any n in there, when you evaluate it at the negative argument, it's going to, because f is even, the f of minus x can be replaced by f of x, but the sine of minus nx is going to be replaced by minus the sine of nx. So overall you've got minus f of x sine nx. So this equation here shows that this product function is odd. And so therefore, when f is an even function, we have that bn, the Fourier coefficient bn, which is the integral from minus pi to pi of f of x times sine of nx. This integral is going to be 0. Okay, so we've said above that whenever a function is odd, its integral across these integrals centered at the origin will be 0. Well, here we've established that this product function f times sine nx is always going to be odd when f is even. Okay, so therefore the bn coefficients will be 0. On the other hand, we could say, continue up here, on the other hand, if f is odd, well, if f is an odd function, then the product of it with the cosine function is going to be an odd function. F of x times cosine n of x is odd. Just give a little explanation of that, because when you take f of minus x cosine of minus nx, what is this equal to? Well, because f is odd, the f of minus x is going to be minus f of x. Cosine remains an even function, so cosine of minus nx will be cosine of nx. So this here shows you that this product function f times cosine of nx is an odd function. So therefore, when you integrate it to give one of the coefficients an, so this will be for n greater than or equal to 1, when you integrate this across minus pi to pi, you're going to get 0. And a naught, oh sorry, in fact for these Fourier coefficients there should be a 1 over pi factor in front of the integral, but that won't affect it being 0 anyway. And the coefficient a naught, which will be by definition 1 over n pi times the integral from minus pi to pi of f of x dx, this is going to be 0. And just like we said at the start, when f is an odd function, this integral is 0. So in this case here, when f is odd, the integral is 0 also. So this shows you the effect of the objective function being odd or even on its Fourier series. Basically half the Fourier coefficients are going to be 0.